Hello everyone, this is Mr. Appel, and today I'm going to teach you a little something about rational expressions. Rational expressions. So in algebra, what do we mean by a rational expression? Well, a rational expression, the fancy way of describing it, is the quotient of two polynomials. Well, what does that mean? It just means anything that's a fraction is really all it means. So technically speaking, 3/4 is a rational expression. But what we're really referring to is algebraic expressions. So for example, something like x squared plus 2 over 5 times x minus 3, that would be a rational expression. Rational just means can be written as a fraction, so it's just an expression that has fractions in it. So it sounds fancy, but that's all it means. So when you hear rational, you should think fraction. Now, some review of the concept of domain, and this is something we're going to worry about domain all year long. This comes up all the time. It's really, really important in anything involving algebraic expressions. So some of this will be familiar and some of this may be new. So the first type of situation you're going to see is with polynomials. So if you remember, domain means what x values can you plug into this function, and can you plug into this function? That's it. What can you plug in and have it be okay? So with polynomial functions, you can plug in anything you want, right? You can take any x, any real value of x, any real number, plug it into any of these functions, and you'll get some real answer. It may not be pretty, but you'll get a real answer. So the domain for any of these polynomial functions that are just made up of polynomials, is all real numbers. Now you're always going to write this in interval notation, so you'll remember all real numbers in interval notation looks like this. Negative infinity to infinity, so that's everything. One little note, when you're entering that into Schoology, which you'll be doing a fair amount this year, you can't really use the infinity symbol very easily, so the way I'm going to have you write it is INF. So negative INF to INF will tell me negative infinity to infinity. And you'll type that in with no spaces. Okay, the next type of situation is with, as we were just talking about, rational expressions. Here we have some x values that we have to worry about for the domain. In terms of fractions, when do we have problems with fractions? Well, you're not allowed to divide by 0. You cannot have 0 in the denominator of a fraction. So this denominator is what we're worried about. So any x value that makes that denominator 0 is a problem. So in this case, there's only one problem. The problem is when x minus 5 will equal 0. And when will that happen? Excuse me, that'll happen when x is 5. So that is the number that can't be plugged into this function. If you plug 5 into that function, it blows up. You get an undefined answer. So 5 has to be excluded from our domain. So our domain is going to be everything but 5. And in interval notation, it's a little annoying, but this is how you have to write it. So it's going to be everything but 5. So it's going to be from negative infinity to 5, not including 5, so we use the paren, and the union of that with 5 to infinity. And I kind of ran out of room there. Let me just move that over. So it's negative infinity to 5, union 5 to infinity. So that's all the numbers except 5. And that's how you're going to have to write that. Okay? The next up is square root functions. So square root functions have a different problem, which is to have a real solution, you cannot have a negative number under the radical, right? You can't take the square root of a negative number or you get an imaginary solution, and we're interested in real solutions. So what we're looking for, we need to find out what x values will keep what's under the radical non-negative. It's okay if it's 0. Square root of 0 is 0. That's fine. It's okay if it's positive. Square root of 0.1 is some small number, but it's real. But as soon as what's under the radical becomes negative, we have a problem. It's not real anymore. So we need to make sure we don't plug any x values in there that will make this be a negative under the radical. So what we need is what's under the radical must be greater than or equal to 0. Because if what's under the radical, the 2x minus 1 in this case, if it's greater than or equal to 0, then we'll have a real answer. So now we just solve this little inequality to find out what x values are okay. Oops, that's a 1. And then divide. And so our domain is all numbers that are greater than or equal to 1/2. So in interval notation, that's going to be all real numbers from 1/2 to infinity, but including the 1/2, because 1/2 is okay. Because again, if you plug that in, 2 times 1/2 is 1, 1 minus 1 is 0, square root of 0 is 0. That's a real solution. Okay. How are we doing here? Okay, moving along. Sorry, had a little technical glitch there. Here we go. Okay, simplifying rational expressions. You should remember this from Algebra 2, but just going to give you a quick review. We want to simplify, or factor, we want to simplify this by factoring. So we're going to factor the numerator and factor the denominator and look for common factors to cancel. It's just like reducing fractions. It just looks funny because they're algebraic expressions. So on the top, in the numerator, x squared minus 3x, we can factor out an x and have x times x minus 3. On the bottom, that's a difference of squares, so that's x plus 3 and x minus 3. And now I see common factors I can cancel, an x minus 3 with an x minus 3. And so my simplified version of that is x over x plus 3. And that is as simple as you can write that expression. I want to make sure you're clear about something. When we simplify, we are saying that the original problem and this simplified version are equal, and that means that if you plug any number in for x, you should get the same thing no matter which expression you plug it into. But that's not true. And that's not true because there are some excluded values, and that's where that domain thing comes in. There are some x values that if you plug in, you get an undefined expression, and so we have to exclude those. We have to write the domain for this problem. So the excluded values are the values that make any denominator 0. So I need to look here before any canceling happened. So what would make this denominator 0? Well, it would be the solutions to whatever would make that 0. And so you'd have to solve that quadratic, and you could solve it by adding the 9 and square rooting both sides, or you could factor the difference of squares and get that negative 3 and 3 both make that denominator 0, so they'd have to be excluded. So your domain in interval notation, this is going to be a little bit ugly, but this is how you have to write it. It's everything but negative 3 and 3. So it's going to be negative infinity to negative 3, not including the negative 3, union with all the numbers between negative 3 and 3, and then also all the numbers that are bigger than 3 all the way to infinity. So this is all the numbers less than negative 3, this is all the numbers between negative 3 and 3, and this is all the numbers bigger than 3. So notice we basically listed everything but negative 3 and 3. A little annoying, but that's how you have to write it in interval notation. Okay, one more thing to do here. Here we go. So, a complex fraction. What is that craziness? Okay, this looks a little crazy. That's why they call it a complex fraction. Aha, isn't that funny? Okay. If you think back to dividing fractions in 6th grade, 7th grade, whenever you did that in middle school, you flip and multiply. Well, that's really what's happening here. We have this whole thing divided by this whole thing. So if you think of this as the main division bar, you're going to flip and multiply. So the problem becomes the original problem times the denominator flipped. So x minus 3 on the top and 8xy on the bottom. And now this is a problem much like you've seen in Algebra 2 that you can simplify. Sometimes it's helpful to put that term because it's a binomial in parentheses and look for common factors you can cancel. So I can see there's an x minus 3 here. There's two x minus 3's down here, so I can cross out one of them. It leaves me with 1. 2 and 8 have a common factor. 2 goes into 2 once. 2 goes into 8 4 times. A y and a y can cancel. There's one x down here, so I can cancel out one of those, which leaves me with 1. And now what's left on the top is just an x. What's left on the bottom is just an x minus 3 times that 4. And to simplify that, to write it in the simplest form possible, I want to go ahead and distribute. So that's going to be 4x minus 12. And that is how you simplify a complex fraction. All right, thanks for watching.